Welcome to the Minnesota River Area Field Investigation 2011. I call this a field investigation, not a field trip, because we are investigating and making observations that are critical for our 8th grade school year in science. There are not going to be any tour guides along the way. Students are their own guides during the inquiry activities that we have planned. Observations that day enhance at least 3 of our units this year, including water systems, erosion, rocks, glaciers. And since we will be outside all day long, it is very important to dress for the weather and pack your own lunch. Our route to our first stop of the day, which happens to be the Minnesota River Bridge at Blakely. It will be a rural drive, avoiding most cities along the way. On the way to stop 1, students will be or should be occasionally looking to see how the topography changes. It starts out as a rolling landscape as we leave Delano, but becomes very flat. This is our first clue or evidence to the history of the area. Here's the view as we approach Blakely. The buses will turn around and drop students off here on the south side of the Minnesota River Bridge. At this point, students will be directed to take in or view the size of the valley. Same location, looking north from the bridge. The task for students at the bridge is to take in the view of the valley and compare how big the valley is to the size of the river, and then to draw a topographical profile of the valley, estimating how deep the valley is and how wide the valley is. As you can see, during flood events, most of the valley floor is filled with water. Students will be asked to look for the sign on our drive to Henderson. We will pass several of these signs. It gives the students a historical look at past flood events, specifically the highest flood on record in 1965. From this view, looking north from the bridge at Blakely, you can see how the flood of 2010 compared to that record flood of 1965. Our route to stop number 2, which is the Gates of Henderson. The dikes are flood control measures that protect the town from flooding. We'll actually drive over one as we approach Henderson from the north and drive through Henderson to the south side to our stop number 2. Looking north into Henderson at stop number 2, we see the dike and the gate that is closed during flood events. Here's the same location. This is our stop number 2. We will be standing on that dike next to Highway 93. Our tasks at the Gates of Henderson. Students will stand on the dike to make observations of the river valley. We'll talk about this structure's purpose, and students will make another topographical profile from this location, including the depth and width of the valley, where the river is located. This is how the location looks during a flood event. Same location, the gate is closed, protecting the city. Another view of the dike system surrounding Henderson. Our route to our final destination, stop number 3, the Rush River County Park. The landscape from Henderson to the Rush River County Park is very flat cropland, as you can see. Another view, and this is another piece of evidence to the history of this area. Our tasks at the Rush River are to make several observations, including how sediment sizes changes as you move downstream, to identify 15 rocks and find out where they are originally found, to brainstorm ideas on how these non-local rocks made it to Henderson, Minnesota, and to draw and observe an erosional feature found in the Rush River Valley. At some point throughout the day, we will also be incorporating digital cameras on loan from the Minnesota DNR. Here's a view looking upstream in the Rush River Valley where we will be. If we turn the camera view 180 degrees, here's that same location. This will be our last stop of the day. We will spend probably an hour or two inside this valley. If one walks to upstream on this point bar, rocky point bar, here's an example of the sediment size you find upstream. As we move further downstream, this will be our view. This is directly across from the erosional feature that I call the cut bank on another rocky point bar. And further downstream, when you look at the sediment size, this is what you find. Can you notice how the sediment size has changed as you move downstream? The day is filled with great opportunities for students to make connections to in-class material and work. If you have any questions, please let me know.